I've been experimenting a bit with these Raspberry Pi Picos recently, and sorry that none of this stuff has come to video yet, but hopefully I'll start to crank out some more of these experiments now so that you can follow along. So I got the Raspberry Pi Pico, but I found a rather interesting kit I wanted to build that uses the Pico as its heart. So this is a standard Raspberry Pi Pico. I've just soldered on some headers so it can plug into a socket. And then this is the kit that I bought from Pi Hut, which is one of the number of vendors that I've been using to buy the Raspberry Pi Picos. Some screws there. Right, so we can begin to see what this is now. So this has got a display in here, so a matrixed dot display. Let's see if I can open this up. There's no screws in it, so it should come apart. Okay, so we can see inside now. So we have a backup battery, we have the slot for the Raspberry Pi Pico, there's a beeper here, there's obviously a power supply section here, a light sensor, USB power socket, and some buttons down this end, some little recessed buttons. And I imagine this is the real-time clock chip. Let's have a look. Yeah, so D8323 it says. So this is the RTC chip. So this is going to store the time in non-volatile RAM. So this is actually a clock. So this is a clock kit driven by the Pico. Oh, it pops out. Okay, so there we go. And you can see the display there now. So you've got this matrix of white LED, so you can, put the time in a big font, maybe scroll other messages. We'll see what we can do with that. And then so it's got some other legends here: day, temperature, AM, PM, and so on. So I just need to program my Raspberry Pi Pico and plug it in, and we can begin to see what's what. I was just looking at how the Pico plugs in here. This is quite interesting actually, because there's a couple of push pins here. So you see these make contact with the top of the board, so the pressure from the spring is going to keep that in contact with the pad. So if you look at the underneath of the Raspberry Pi Pico, you can see that the USB interface there has got a couple of little copper pads there. So basically this is made so that the push pins are going to contact the USB interface. So when this is all fully plugged in like so, and all of these are in the right sockets, it's a little bit difficult to get that in place, but there we go. So that's pushed in there now, and now the push pins are there contacting the USB interface. So that's quite neat. So I imagine that, well, we'll try it in a sec, but I imagine that when I plug this into the computer, I'll be able to program the Raspberry Pi Pico through this external interface. Right, so if we look at the information online about this Pico clock, so I bought it here from Pi Hut. There you go, you see it's $23.50 at the moment. which is about what I paid for it. But the actual thing is made by Waveshare, so they link you to this Waveshare site, and this seems to be a company with a lot of interesting electronic products actually, so I'm going to spend a bit more time looking through here and try and figure out what things I might want to look at. But they have this wiki page here which is of interest to us, which is how to actually load and drive the thing. So we've got this is how to download the code on Linux using wget, but we can also just take that link there, and we can on Windows we can just paste that in a browser and it'll download the file. So we've got Pico clock here, so we'll unpack that in a minute. The source code for this is written in C or C++. I'm not sure actually which it is. So this ready-made build, this binary, this UF2 file is a binary. This binary is something that we can load directly into our unit and it will start functioning as a clock. But all this stuff is open source, so you can mess around with the source code and build your own version if you want, and I do plan to do that myself. I also found the other day that somebody had created also a MicroPython version of the clock software as well, and I'm very interested in that, and I will probably look at that in a future video. Well, let's plug in and see what happens. Okay, so it's been recognised. Of course, I haven't loaded any firmware into here yet, so it'll be whatever was on the Pico before. And so if I start Tony, so this is the application that I sometimes use for testing things in Python. Okay, so we've got MicroPython running on this Pico, one of those tiny units. Yeah, so we're running the MicroPython on this Pico. I don't know, Pico, Nano, Micro. We've got all of the tiny measurements here, haven't we? So we need to reload this with the new firmware, and the way that we do this, I'm going to have to unplug it again so I can open the box. Because the Nano has got quite a handy feature. It's actually got a button on it, so sometimes you, like with the Arduinos, you sometimes have a problem that you can't properly load them because there's no way to kind of override it by pressing a special button. But the Pico has a special button, so if we hold this in, then when we plug it in, it'll power on in a special boot mode. So there we go, new thing has been recognised. And so if we look now, this drive D has popped up, so we can actually see this Raspberry Pi RP2 drive, and all we need to do is actually drop the file in there to make it work. So let's have a look in here. How do we unpack this? Oh, there we go. So if if we look inside this folder, we've got, so these are the C files, so these are source files. We don't really need the source here, we just need the final built executable. So that's this UF2. So a UF2 is a executable that can run on a Pico. And there we go, it's rebooted now. And there we go. So it's got the time on it. Just slip the back on. So now basically we just have to set it. So we've got the buttons here on the side. So that top button obviously sets into the mode where we can change all the parameters. Middle one is going centigrade Fahrenheit, and the bottom one says auto light. Alright, so that's automatically changing the brightness, because remember there was a brightness sensor inside it. So if we try and set it, so the time is actually 16:18 at the moment. 2021 is right. 5th of October is correct. This is for beep on. I don't generally like beeping, so I might try and, there we go, beep off. DP, I can't remember. Let me see if I can find the reference page. Yeah, so let's go through that again. So BP is for beeping, so we'll go beep, beep off. Okay. DP is for scrolling. I don't know what that is, but should we say on? Oh no, gone wrong now. MD is 12 hour or 24 hour. Alright, so that just timed out on me. Not moving quick enough, am I? So beep is off. Scroll we'll leave off for now, shall we? MD2 is 24 hour system, and FT is hourly ring signal, so I'll leave that off. So there we go. So that shows, so that's got battery back time now, and so if I unplug it, the RTC chip will remember that time for when I plug it back in again. So let's just try that. Right, so it beeps and then it shows you the time. So it obviously just showing the software version number there as well at boot up. Okay, great. So I might just switch on that scrolling mode again, see what happens. Did you see the beep has actually switched back to 1 now? DP on, 24 hour, and the hourly ring signal off. Okay, well, I mean, that gives some sort of idea of what this does and how to initially set it up. So as I say, in the future I'm going to be looking at seeing if I can understand the source code and see if there's anything that I can usefully change and make my own special version of the software. Until then, thanks very much for watching, and See you in the next video.